To all of you. Let us begin the next session on classes and the objects. Let us review the session number 4. So, in the last session, we had discussed about the object-oriented concepts. That is how it is different from procedural or the structured programming languages, and what are the basic characteristic of the object oriented concept that makes different from the procedural or the structural programming languages. And we are also discussed about operator overloading, that is how the operator overloading can be used in the Python programming. And then a very important feature of the Python programming, that is polymorphism, we have discussed it. So let us go into one more important property of the object programming language, that is called as the inheritance. Let us take for example here there is something called as the playing the cards. So we have 4 suits, each of 13 ranks. So totally 52 cards we have, right? Mapping of suits and the ranks to integers, that is how many cards you have it. And basically there are 4 suits here. The spades is 3, hearts is 2, and the diamonds are 1, and the clubs is 0, right? So there are totally 4 suits you have it. And the number of ranks here, right? Ace is 1, ace which is considered as 1, and 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 10, and the jack is considered as 11, queen is considered as 12, and king is considered as 13 here. And the class definition for a card looks like this, that is the class card, right, represents a standard playing card, right? So the definition, there is an initialization for method we have it, that is suit equal to 0 and rank is equal to 2 it is. That is self dot suit equal to suit and self dot rank is equal to rank it is. Then we have something called as queen of diamonds equal to the card 1 and 2. That is suit is initialized to 1 and the number of cards can be considered as 12 it is. That is this is how you can represent the card for the playing card using the class. That is, we have the initialization method, that is self suit is initialized to 0 and rank is equal to 2, and self dot suit equal to suit here, and self dot rank is initialized to rank, and the queen of diamonds which is equal to card 1 and 2. One is suit is equal to 1 and rank is equal to 12 it is. And let us try to bring more thing into the playing cards. We have something called as the class attributes. Variables which are defined inside a class but outside of any method are called as the class attributes it is, right? So those cards are those variables which are defined within but inside the class but outside any of the methods are called as the class attributes it is. So let us look at one example here. Suit names and the rank names are considered as attributes because they are inside the class but not inside of any of the methods. So, okay, so that's why they are called as the attributes. So, and the suit names is equal to clubs and diamonds, hearts and spades, and the rank name is equal to none, ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen and the queen. So, okay, these are all the rank names we have it, and the suit names, clubs, diamonds, hearts and the spades. And these two lists we call it as the attributes of the given class because they are written inside the class but outside the methods. And we have something called as the definition str self written card dot rank names self dot rank, right? We're just returning the return value of from this string method, and the card dot suit names self dot suit, right? And we are creating an object here, that is a card is equal to card 2 and 11 here, and then we are just putting something called as the card 1. We are calling the card name, sorry, object 1, that is card 1, so it prints something called as the jack of hearts. It prints something called as the jack of hearts it is, right? So that is how you can use or you can declare the attributes within a given class. Okay, an attribute is something like variables which are defined within a class but outside of any methods are called as the class attributes. So here are the two class attributes I have it, that's the suit names and the rank names, right? So okay, this is the classical representation of the or the diagrammatic representation of the things. So card is the type here, or card is a class name, right? And the type suit names and the what you call it as the rank names, and you have two lists here, that is suit names and the rank names. They are nothing but the what you call it as the two list we have it, and I am creating an object of the given class called as a card, and that is going to have the value called as suit is equal to 2 and rank is equal to 11. Suit is equal to 2 in the sense this 0 1 2, right? 0 1 2. So okay, hearts is nothing but the suit 2, and rank means 11 in the sense so 0 1 2 3 4 5 6 7 8 9 10 11, right? Jock that will be returned, and we are just returning jock of what is that the name called as the car dot rank names self dot rank. What is that? Rank is having rank is having 11, right, which is nothing but the jack, and the suit name is what the hearts, so we are just printing it jack of hearts it is. So that is how the the class attributes looks like. A class attribute is nothing but a variable which are defined inside a class but outside of any method, or also referred as the class ref. And for built-in types there are relational operators, that is less than, greater than or equal to, etc., that compare values and determine when one is greater than or less than or equal to another one. So there are some built-in relation operator that we are already familiar with. Relation operator, that is less than, greater than or equal to, etc. We have it, greater than or equal to, less than or equal to, or not equal to. They are all called as relational operators, and they are basically used to compare one value with another value, whether the first value is greater than or lesser than or equal to or not equal to, and so on. For programmer defined types, one can override the behavior of the built-in operators by providing a method named underscore lt, which stands for less than. It takes basically two times parameters, one is the self and the other, and returns true if the self is strictly less than the other. So it basically takes two arguments, okay, or the two parameters. One is self, that is the object we are invoking, and second one is the another object which you are want to compare with, and the return value of this lt is true if and only if self is, or the object self is strictly less than the other object it is. The correct ordering for cards is not obvious. For example, which is better, the three of the clubs or the two of the diamonds, one has a higher rank but the other has a higher suit. Okay, so basically we are using what you call it as the relational operator to make a comparison between one object with another object, or one value with another value, to know whether the first argument is less than, greater than or equal to, or like greater than or equal to, lesser than or equal to, or whatever it may be. And there is a defined function called as the underscore lt, which checks whether the second argument is greater than the first argument, or in other words whether the first argument is strictly less than the second one or not. And here is the one thing, that is comparing the object, comparing the cards using the underscore self and the other. Check for this. If self dot suit is less than the other dot suit, you just return a true value. else if what is that, if self dot suit is greater than the other suit, then return the false value. Okay, and it just check it, that is the self dot rank is lesser than other rank or not. Okay, so it actually returns the whether the true or the false value. So okay, this LT, it's basically returns a true value if the first object or the value of the first object is strictly less than the other object, or if it is greater than the other object, so it returns the false value, right? And more you can also write more concise definition here, that is T1 is equal to, that is self dot suit and self dot rank, and T2 other dot suit and other dot rank. Okay, and what you do is that I'm just returning T1 is lesser than T2 or not, whether T1 is lesser than T2 or not. If T1 is lesser than T2, it returns a true value, else it returns a false value. And let us try to understand what you mean by a deck. A deck is made up of cards. It is natural for each deck to contain a list of cards as an attribute. A deck is basically made up of cards. It is natural for each deck to contain a list of cards as an attribute. The underscore init underscore method creates the attribute cards and generates the standard set of 52 cards. It basically attribute cards and generates the standard set of 52 cards. So let us now try to understand what do you mean by deck or how to create the decks here. So we are creating a class called as deck, and within that we have a method called as the initialization method, and self dot cards is initialized to 0. It is self dot cards is initialized to 0 for you each suit in the range 4, and for rank in range 1 to 14. What I am doing is that I am creating a card here. I am creating a card. There are 4 suits, and each suit can have a rank of 1 to 14. Alright, so there are 4 suits, and each suit is having a rank from 1 to 14, that comes around 52, right? So that's why card is equal to, so for each suit we are creating or we are generating a rank. That is for A we are generating diamond, heart, and what is that, diamond, we are creating clubs, diamonds, hearts, and the spades. So like this we are actually creating 52 cards, and these 52 cards we generally call it as the decks. Right, it contains a list of all the attributes. And here is one more method for the deck here, underscore string self result equal to is initialized to null for card in self dot cards, right? Result dot append string card it is, that is for each card in the deck. For each card in the deck we are just looking at the card, and we are just putting one card into the deck here. So that is how you can use the string string method to insert a new card into the deck. This is how you can generate the cards and place it in the deck. And to deal with cards, we would like a method that removes a card from the deck and returns it. Okay, so to remove the card, right, so there must be something which is going to remove the cards. Okay, so to remove the card from the deck, we have function method called as a pop underscore card, that is self dot cards dot pop function. And to add a card into the deck, we have something called as add underscore card self card. So okay, self dot cards dot append card. To shuffle the cards, we can see the random method shuffle. So okay, what is that? Shuffle self it is, and random dot shuffle self dot cards it is. Okay, so these are the functions. And to sort the cards, we can use the sort method, that is a sort the given object, that is self dot cards dot sort function it is. So, okay, these are the four functions which are so four methods which are basically used to add a card into the decks, and to remove the cards from the decks, and to shuffle the what you call it as the cards from the decks, and to what you call it as to sort the cards in the decks. Okay, so that is what we have something called as the right functions, or the method called as the pop card and add card, shuffle card, and the sort card it is. And let us try to understand more about the inheritance here. Inheritance is the ability to define a new class that is modified version of an existing class. It is just an extension, or it is just an new class that is a modified version of the already existing class it is. As an example, let us say we want a class to represent a hand, that is the cards held by one player. Okay, so we want to represent we want to represent a class called as the hand, that is the cards held by one player. A hand is similar to a deck. Both are made up of a collection of cards, and both require operations like adding and removing the cards. The hand is similar to a deck, right? So which is basically used to hold the cards, or it is made up of collection of cards, and both require operations like adding and removing the cards. A hand is also different from a deck, right? So there are operations we want for hands that don't make sense for a deck, right? A hand is different from a deck, right? So this relationship between classes, similar but different, lends itself to inheritance. Okay, so there is a similarity between the deck and the hand. Okay, so we can extend the property of a deck into another class called as the hand. So that property we call it as the inheritance. To define a new class that inherits from an existing class, you put the name of the existing class in parentheses. Okay, if you want to inherit, or if you want to extend an existing class, what you can do is that you have to include, or you have to put the name of the existing class in the parentheses. So here is one example of the inheritance. Okay, so class hand which is going to inherit, or which is going to extend the property of an existing class called as the deck. Okay, and so we have something called as initialization method. Self label is equal to, that is self dot cards and self dot label. So so label here, and hand is equal to new hand, we are just creating it. Deck we are creating a deck function here, and card deck dot pop cards, our hand add card into the card here, right? So both of them are going to create an object here, and we are just adding one card into the what you call it as hand, right? So that is how we can do the things. That is, we are creating or we are extending the property of a class called as the deck by another class called as the hand. And what I am doing is that this hand is a new class and deck is an existing class. We are extending the property of the deck. So then what we have is that we are just removing one card from the deck and placing it into another class or another object called as the hand it is. Then we are just what you can do is that we just print the collection of cards that is there in the hand. And here is one more code snippet that is going to remove or moving 5 cards from the deck to hand here. So we are creating an object called as the deck of the deck class and shuffle it, right, and move 5 cards from the object called as a hand to hand 5 and hand sort and the print. That is, you just move 5 cards from deck object into hand object. Okay, you just move five cards from deck object to hand object, then sort it and print the collection or the print the cards what you have in the hand details. And let us try to understand what you mean by a class diagram. A class diagram is a graphical representation of the relationships. That is how the relationship between any two classes can be represented using the class diagrams. There are several kinds of relationship between classes. Objects in one class might contain references to object in another class. Okay, there are some relationships between the classes. That is, object in one class might contain references to objects in another class. For example, each rectangle contains a reference to a point, and each deck references to many cards. This kind of relationship called as as in a rectangle has a point, a deck has a card, and one class might inherit from another, right? And this relationship is called as a easy. That is, a hand is the kind of a deck, right? So is nothing but it is a form of the what we call it as inheritance, right? That is going to show you the relationship between one class with another class, or in other words, a class is inheriting the property of another class. It is that is what called as a easy. One class might depend on another in the sense that object in one class take object in the second class as parameters. That is, object in one class takes object in the second class as the parameters, or use object in the second class as a part of the computation. This kind of relationship is called as the dependency. That is, one class may inherit, or one class may take the object of another class as its parameter, or it may take the values of an object in computing the things. And such a kind of dependency, such a kind of relationship, we call it as the dependency. So this is how the class diagram represents. That is, a class diagram is nothing but a graphical representation of a relationship, and it has three relationship here. Actually has a relationship, and is a relationship, and dependency. And the arrow with a hollow triangle head represent is a relationship. A hollow arrow with a hollow triangle is called as a is a relationship, and the standard arrowhead represent a has the relationship, right? So arrow with a hollow triangle head represents the is a relationship. That is, hand is a form of deck. It is, hand is a class here. It's a form of deck here, right? So that is the relationship, and the standard arrow represents the has a relationship. That is, in this case, that is, and the deck has a card. Deck has the card, right? And the star near the arrowhead, it represents the multiplicity. That is, a deck can have n number of cards here. A deck can have n number of cards. That is why you can represent with using a star notation. And a dash arrow represents the dependency, right? If you are using dashed arrow, that is that represents the form of the dependency. So this is how we can represent the classes, right? So arrowhead, arrow with a hollow triangle head represents the is a relationship, and the standard arrowhead represents a has a relationship, and the star near the arrowhead represents a multiplicity. The next one, anytime you are sure about the flow of execution through your program, the simplest solution is to add print statements at the beginning of the relevant methods. Okay, and if deck dots shuffle prints a message that says something like running deck dot shuffle, then as the program runs, it traces the flow of execution. Okay, it traces the flow of the execution. As an alternative, you could use this function which takes an object and a method name and returns the class that provides the definition of the method it is. Anytime like you can use you can use simplest functions, right? uh, Print statements at the beginning of the relevant methods to go through your functions. Okay, so here is one example here, that is a definition, find defining class, object, method name, right, method name for ty in type object dot mro, right, if method underscore name in ty dot dictionary, so okay, so return the ty, right. So here is an example, that is hand we are creating it, and find defining class, hand and the shuffle, that is the name of the class is class and dot deck it is, that is MRO method gets the list of class object types. MRO stands for method resolution order, which is the sequence of classes Python searches to resolve a method name it is. It is a sequence of classes Python searches to resolve a method name it is. And debugging principle, when you override a method, the interface of the new method should be the same as the old one. So okay, when you override a method, the interface of the new method should be same as that of the old one. It should take the same arguments as return the same type and obey the same precondition and the post conditions. If you follow this rule, you will find that any function designed to work with an instance of a parent class like a deck, you will also work with instances of a child class like a hand and the poker hand, right. The basic principle of the interface, that is a method overriding, is that your class name must be same, your method name must be same, and it should carry the same number of arguments, should return the same type as well. Okay, and if you follow such rules, anyone can create an instance of a parent class and you can use it. If you violate this rule, which is called as the substitution principle, your code will collapse like a house of cards, right. You just if you don't follow this rule called as the substitution principle, your code will collapse like a house of cards it is. That's why when you are writing the overriding methods, you have to follow these rules correctly. That's all for the session. That is the end of the module number 4. Okay, we'll begin the module number 5 in the next class. Okay.